Welcome, everyone, to the Real-Time Field Science Application ESIP session. I hope everyone is caffeinated and their bellies are full and everyone's excited about this session. The goal of this session is really to start the conversation between users and developers and people really interested in learning about real-time field science applications. Some of the themes revolve around like the UX design as one, and thinking about various ways in which we can put our data together or layer our data to tell a story, to get a different perspective on our data, to discover new features in the data that we hadn't seen or discovered before using these tools. This is the first topic of its kind at ESIP. So let's see where it goes and what develops from that. So we have about a dozen attendees in the room and maybe half a dozen people online on Zoom. Bobby's going to be monitoring the Zoom. Thank you, Bobby. Our session is about an hour and a half. We will have 5 10-minute talks with some room for Q&A. These are folks who will talk about their applications that assist in real-time data visualizations, tracking and documentation for Earth Science field campaigns. So at the end of the talk, we're going to have about 25 minutes for panel discussion with some Slido audience participation, so we discover who our audience is. So let us begin with our first speaker. I'm going to bring that up. So our first speaker is Trevor White. And he is coming from the flexible array of arrays and mesonets, aka FARM, from the University of Alabama in Huntsville, and he's going to present on the Guru application.
So I'm Trevor White. I am the reclusive in-house software developer at FARM, out of my cave for the first time in 10 years to chat with you all about Guru 2 and alpacas. For anyone unfamiliar with what we do at FARM, we're known for our hurricane research, our tornado research, and our cool radar trucks. To introduce you to Guru conceptually, Guru is a geographical unified radar utility, something I've designed to try to assist with the process of doing research with mobile weather radar at really every point in the research enterprise, from being in the field to post-analysis. I think more important to our conversation here is why is Guru. When I really first started getting into research radar data, I found it quite impenetrable. I requested a couple volumes of DAO data to verify my dual Doppler code, and there was no Windows program to actually let me view the data and interact with it. At CSWR, where I worked at the time, we needed a better data analysis environment that was really richly interactive and let us really get in and really feel the texture of data. As a geographer, I really wanted to build some software that had a geography first approach, where any data that I supported, I can geolocate to within as perfectly as possible, and anything I can't, I just don't support. We needed an analysis tool development sandbox for building better tools to use in radar research that actually feel good to use. I'm not sure if anyone's ever used Solo 2, for example. Great piece of software. Not as interactive as one would love. But most importantly, I'm sure Python devs can sympathize here. I just wanted something that wouldn't change on us when I stopped looking at it for 6 months. So this is what the original version of Guru looked like, where we really got started. This is a tornado analysis tool where you just click and drag a circle around your tornado and just sort of tweak it until you feel like you've got the best representation in this kind of kinematic analysis. But we did this for 5,000 sweeps during a particular study we were doing. I quickly moved on to Guru 2, which is what we now use in our real-time operations. It's built to let you view as many radars at a time as you want, add satellite into the mix, NOAA, MRMS, really whatever you want to load and use in real time, you can. It's supposed to be highly flexible. So you can do something like this, where you've got one radar and 4 products up in 4 panels. You can view 2 radars at once in your 4 panels. You can get kind of weird with your panels and do that if you really wanted to. But that gives you the flexibility to do things like this, where this was my view during the Lee project in real time, where I had my data frame over here. Is my curriculum visible? Yes. I have my data frame over here with a surveillance scan in it, and this marker showing where my RHI went through. So I really am able to spatially contextualize this information that is sort of otherwise stripped of its geography. I guess I'll just admit, because why not? So you can also view all kinds of exotic data in it, depending on what instruments are in your field campaign. This is from Vortex 2, 1995. This is airborne Eldora data, contextualized against this WSR88D data. There we go. It's built on a custom Direct 3D11 pipeline. So I built the whole renderer from scratch, translating basically radar and all the geography into basically video game world, including down to using a paper written by Valve Software about their game Team Fortress 2, about their text renderer. I had to write a custom text renderer to get this working. And then most importantly, Guru scales well with hardware specs. So it runs pretty well on a laptop, but on a desktop, you can generate publication quality plots at 200 frames per second, if you wanted to. We had our first real test of Guru 2 doing real-time operations during Relampigo. This is the operations center down in Villa Carlos Paz, Argentina. You can see on my screen there, I've got, I think that's Dow 6, 7, and 8, reflectivity and velocity, with some dual Doppler lobes labeling where our actual dual Doppler coverage is, so that PIs could tell in real time kind of the nature of the data we're collecting, and if our storm of interest is actually in a region we can do analysis on. This really sent us down the rabbit hole of design, and led me to build alpacas, which, probably inclusive of all of everything here, that acronym is probably my best work. It's the Adaptable Lightweight PHP API for Coordinated Atmospheric Studies. Really, yeah, that's my favorite. It provides rigorous authentication, so the channelized chat that you get access to, you're not going to be able to see like the PI chat if you're just a gopher like me. It allows you to feed positions into the fleet through multiple avenues, notably Garmin inReaches, which are satellite communicators. So when folks don't have cell signal, we can still get their locations for situational awareness. There's an app called OwnTracks that I use on my phone that also will feed locations to alpacas. And then Guru itself will also feed locations if you've got a GPS plugged into it. We can share deployment layouts, including our dual Doppler lobes, through alpacas. And also importantly, share annotations to really complete the multiplayer radar application experience. So other people can draw on your map, drawing polygons or, I don't know, like a fork if they think a storm's done. So this is what a standard Guru 2 user experience would look like. This is from our project Ice Chip last year. So I've got my data frame set up so I can dock my chat over here. You've got this purple whoa, how did I do that? Cool. You've got this purple polygon that Victor defined to show us our target storms. We've got our dual Doppler lobes here that communicated where that coverage was. And you can draw these various polygons. I've got this fake, hail swath polygon that I drew, for example. You can also draw freeform plots, just really mark up your buddy's radar screen any way you want. if people aren't watching chat, we also have the option of just putting an alert like that right in your face on the screen. If the IOP is over, or if there's a huge tornado elsewhere that we care about, we can communicate that pretty rapidly and effectively just by putting angry text on somebody's screen. This is the type of information that would have been available in real time. You see my dot sort of crawling there along the south side of the screen. I was feeding locations via my phone in this particular. Oh, thank you. In this particular loop, everyone else is feeding locations via Guru, so theirs are 1 minute incremented. So you can sort of see, like, the fleet kind of bites up on those storms to the north, and then ends up coming back down and deploying instruments here. This interface is sort of how we would deploy instruments in the field. I implemented GPS pucks in Guru, so you can basically just click a button and say, "Hey, I put down pod K here," and it'll generate a durable record both on the laptop and online that instrument was deployed at a certain time. Instruments that you're close to that you could retrieve will appear in that box. I was in Boulder when I made this visualization, so I am 600 kilometers from the nearest instrument. If teams are it's late at night and teams want to help each other out and retrieve each other's instruments, they can, and they can signal that they have, and that all of course goes out via alpacas in chat. The challenges of doing things this way. My number one challenge has always been Intel versus NVIDIA and AMD hardware. Some things just inexplicably don't work on Intel. I have 1,000 war stories about that that I'll save time by not going into. And the other thing is, I am not a full-time dev. I'm also a part-time truck driver, part-time radar operator, part-time truck washer. There's a lot of things you got to do to make field projects go where the rubber meets the road, and it's not always development. Just in terms of future plans, sadly, I mangled this slide. I'm intending to really more deeply integrate Guru into the radars, so we can see every single pulse that we're sending out, look at the actual waveform, using these fast graphical APIs, view like waterfall diagrams of Doppler spectra as you collect data, so you can keep an eye on signal issues, tuning, and then some more API changes to help me get a better idea of API health and user connectivity in real time. Super excited to get that dashboard rolling. But these are the data sets that I use in my examples. Any questions?
So we have a few questions, and for the speakers that are online, I'm going to hand over the mic so that when it's recorded, people will hear the questions.
Hey, good talk. So you mentioned having issues with Intel versus NVIDIA and AMD. What I have found to work, and maybe you have tried this already, have you tried the Vulkan API?
So I'm using SlimDX, which it's a managed wrapper around like Direct3D.
Okay.
My application's written in C#. I haven't heard of Vulkan though.
So it's a GPU library. It's C++ though, so getting that to work might be a pain a little bit. But if you're having the hardware issue, maybe see if you can get something through Vulkan over, because there are plugins that you can use to go through those things, and it also works on Mac. So
well, one of my big issues was Intel hardware doesn't like writing to a final texture of integers. It just prefers floats, so it just doesn't work. Oh yeah, it's quite something sometimes.
Did you use any of the Elrose packages for this? You mentioned Solo too, and
so I definitely looked at some of Mike Dixon's notes for sure when I was writing some of this, but pretty much did all of our own stunts on this one. I think I used some Dorad library stuff from Elrose, but other than that, I have a hard time using code that I didn't write, because ultimately I'm accountable and responsible for it, and not really knowing it because I didn't write it is tough.
Really cool talk. So I do a lot of similar stuff with the Vortex USA program. I was wondering if you had thoughts or suggestions like bandwidth. Obviously, being in the field, bandwidth is a concern. I joke around that like what I would pay to be a software developer that could rely on 100 plus megabit download speeds.
Yeah.
I guess what are your thoughts? How do you work around that? Assuming that, when you're in the middle of nowhere, you've got next to no speed.
We are actively thinking about that. We've been lucky in that most of our ice chip operations I think basically all of them were in areas of good cell coverage. We typically will carry around like AT&T and Verizon hotspots. We've just started experimenting with putting Starlink on one of the DAOs. That's really helped us like actually push out data more reliably from in the field. But yeah, like right now we're still challenged by the spotty cell network, especially like in like Southwest Texas.
Thanks, Trevor. Let's thank our speaker one more time. I think we have to move on to our next speaker. Our next speaker is Chirag Shah from Oak Ridge National Laboratory, who will present the ARM Field Campaign Dashboard.
All right. Hello, everyone. My name is Chirag, and I am here to talk about ARM Field Campaign Dashboard on behalf of several folks back there at ARM. So you might be wondering, what is ARM? And sorry, before I jump onto ARM, just a little bit about me. I am a data science engineer by background. I work on a lot of things, including data tools, AI, and I'm also part of AI in core R team. So it's a lot of data tools, data management, data portfolio overall. And just a little bit about ARM. What I'm going to share is what ARM does overall and what ARM as a user facility means. So ARM is atmospheric radiation measurement, and it's one of the big science national user facility operated by Department of Energy. And it's a multinational laboratory operated facility, and it does a lot of critical role. It does have a lot of role in advancing atmospheric and Earth system research overall. And over past 30 years, I think ARM has done about, data collection from different platforms such as areas, fixed sites, mobile facilities, and whatnot. And overall, ARM Data Center is the center of all collection of ARM. And it has been collecting more than 3,000 data streams, about 3,000 data products, about 11,000 data streams. And this year, we are almost projecting about 8 petabytes of just atmospheric data. So that's a lot. And over a month, we do collect about 50 terabytes of data from the instrument source all the way to, reprocessing and processing and then making it available to the user community. So ARM, as I explained, ARM does a lot, and ARM Data Center is like the center hub about making this data available to the user community. And while it's doing this through different venues, through fixed sites, mobile facilities, aerial platforms, and whatnot, you do need a lot of platforms to make this data available. So just in this bubble, you can see we have a lot of data networks in terms of where the data goes. You have a lot of science metadata, so it's also interoperable in the sense like, hey, we have different formats that supports, including ISO, schema.org, FGDC, and whatnot. And then from the data access level, we have a lot of APIs and a lot of services to make this all interoperable. And you can download it just using simple Swagger-based documentation or through API platforms. And then there are also several data portals where you can see this data all available. Now, speaking of field campaigns, as I said, ARM does a lot of data collection through fixed sites. So in essence, there are 3 main fixed sites that ARM has over US, which is around Southern Great Plains. There is one in Eastern North Atlantic, and then one is in North Slope of Alaska. And then as an ARM mobile facility, ARM provides a lot of proposal-based field campaigns opportunity where a PI, co-PI can propose their own field campaigns in remote or different like in situ or remote observatories. And then you can collect this data. So over this FY, there were about like 44 ARM mobile facility campaigns proposal. And then there were also a decent amount of aerial facility proposals. And then all the fixed sites that's all goes around. There's a lot of field campaigns that going around, right? So you might ask, what's the challenge, right? In this case, when you have so many field campaigns going around, it's a lot of things going on for the user community. Like in the sense, you have this whole operational science communication defragmentation. You have this research groups who are, all across different observatories. This includes PI teams, site staff, instrument teams, general arm staff. How do they do communication, right? There is also so many data sources. There are so many visualization methods available. What Trevor showed is one beautiful aspect of just, seeing the radar side of things. But there are also instrument data sources. They want to see images. They want to see site-specific observation. How do you all make this all centralized and one dashboard or some sort of capability, right? And then scalability. Campaigns, they're not going to stop. They're just going to keep happening. And how do we make this reusable in a way that it does make an impact by, we don't have to put more effort on creating this for every campaign, but it's also, it's inefficient in a way. And it's not, we want to make something which is not hard to maintain or it's not resource intensive, right? And at the end, it's also the barrier for the user community. So once they do get into a platform or something, there is always this entry barrier for data interpretation and things like that. So how do you interpret, or like how do you navigate, make sure that the users, they can navigate through this all complex data sets that ARM collects, and then it's also available to the science team members or external researchers. That's when the whole idea of about the field campaign dashboard come in here. This is just an interactive, just a screenshot of like what all dashboards we have overall, about supporting more than 15 dashboards at this point. And then, it's in a way providing users the ability to, come in at a central place. They can see a lot of things. You can have their own calendars. You can have different reporting mechanism. What if they are operating on site, or if they're on in their offices, if they want to communicate with the site technicians, if they want to communicate with the site manager, how they're going to do it, right? So that's where the whole idea about the field campaign dashboard comes in. And here I'm just going to give a recorded glimpse of this, just in case the demo gods are not with us in that case. But feel free to also visit the adc.arm.gov AFCD, which will take you to this dashboard, which is a web-based dashboard. And I'm going to quickly run along with this view where you can, with the calendar view, you can see some discussions happening. You can see the instrument-based data plots. This is, again, near real time. You can go ahead. All these data plots are generated through Data Quality Office through ARM. And there is an opportunity for the PI or the site technicians to insert. And again, this is all data-driven. So if you have a need to add any more fields, schema changes, what all fields you want to add, you can put in comments. You can send email directly via this dashboard. Get in touch with a technician. Get in touch with a manager. If you want to take a look at the data plots, the first view that we give is the last, or like the current week. But if you want to go in last month's view, do some comparisons, you can go ahead and visualize this. This is also something we recently added, is like a map layer. Again, all thanks to NOAA, NASA, all the open source imageries available out there. All I had to do was just point to them and get them, so that's the best part about interoperability and the open source versions of this. So here it's like a open layers version of it. What I'm trying to show here is like next-red data sets. Again, this is communicated through PIs who are interested in looking at what all radar data they want to see real time, what all NASA satellite images they want to see. If they want to see vegetation index, they can. It's just one simple addition in a database field, and we can make this available real time. Also, there are several ARM tools. Like I said, I work on a lot of data tools, and ARM has a lot of tools that's made to the community. One of these is the PM and CM reports, which are called as preventive maintenance and corrective maintenance. So if there are issues, again, with your instruments or some calibration is required, they don't really have to leave this tool. They can just go in, make that tool go, and then they can insert their data. And this is the data discovery, which is ARM's flagship tool, where they can make the tool available, or the data available. They can really go back into, looking at their data collection from that aspect and go ahead and download it. Also, the context view, sometimes, as I said, there are teams involved in field campaigns. You can have 30 plus members easily. It's very hard to forget who was involved, who was not. And then when you really want to get in touch with them, all these contacts and ask support that gets going. That's what makes the field campaigns going. Change the slide. Okay. So from future scope perspective, again, this is always evolving. Like what we are seeing with field campaigns overall, there are so many ways of sharing data. Again, right now, we just have this very specific to ARM. It is tailored to ARM needs, to ARM field campaigns and ARM PIs. But again, this is not an issue just for me. It could be an issue for everyone else. So what my plan is going to be, or what our team's plan is going to be, is like do feature enhancement, make this architecture more centralized or standardized. So there can be APIs, so they can just use this to connect external sources, or they can download the same reports that what they feed it in. Also do some cross-campaign and analytics and searches, since ARM is all about atmospheric data. There is a scope where you can, do data queries across different campaigns and try to bring this. Dynamic FAQs. So, sometimes when field campaigns do happen in urban areas, rural areas, there are things that you as a scientist, you want to share with the community. And then you're creating your own knowledge base, which is somewhere in the notebooks or it's somewhere in the web browser. But that's this way the dynamic FAQ can help scientists create and share it with the community. And then, of course, AI is everywhere. So we can also do augmentation. Like all of this is data. So you can have like a conversational search box sitting on top of this and then get the conversational style queries and questions asked so that it can help the PIs. That's pretty much it. But again, there's a lot to share. This is just a 10-minute overview. But if there is something that you would like to get in touch with, here is my email and also ARM Data Center's email. Feel free to visit the AFCD website. Thank you.
Ooh, sweating, just like watching all of that information flow by. Does anybody have any questions for Chirag?
Thanks, Chirag. Great talk. So something that I've noticed, I think, especially in the last 4 years, is that much more data is available in this open source context that you're talking about, with easy access to get to those NOAA data sets and things like that you can map. Do you think that's really opened up the door to make these kinds of tools contain all of this great data in an easier fashion?
Oh, definitely. I definitely see there is a point, because now if I put this in my shoes, the way I had to, the first time when I started integrating this just within ARM Field Campaign, it took me a month just to understand the APIs, the protocols, what's all needed and everything. But now imagine if I can share this with a broader community. Hey, this is what my experience was looking like. And this is the same exact playbook, a playbook that you can use to use the NASA or NOAA data sets in a similar fashion. I think it's just going to help them, right?
Yeah. Thanks.
I'm sorry, did I answer your question? Sorry. Yeah.
We have time for a quick question. I have a question. So when you're incorporating those APIs, have you ever had that experience where the API keys like break because someone on the other end has decided to change the way that they do APIs? Because I know that has happened in the past for a lot of operational centers that are incorporating APIs. I was just wondering what your experience with that is.
That's a good question. And yes, that has happened, because a lot of these operational APIs, they do go through certain maintenance periods. And as a developer, you have to keep an eye on those maintenance periods and really keep an eye on the version changes and what exactly changed. Because one of the things that I experienced was, so NASA's EOS DIS, they made a change to their global world viewer, and they really outdone everything with a Python-based API. Previously, it was all Java-based API. So the parameters and the URL constructs were all different. And it took a while just to, the first developer take is like, oh, what could have changed? But no, you have to really go through the version changes and the change log just to make sure your API is consistent with those operational periods. And then also look at the time when they're going to do the maintenance. So you can put relevant maintenance alerts on the tools itself. But yes, that's a big dependencies with operational APIs that You have to keep an eye on the maintenance downtimes and then communicate that with the community as well overall.
I know a little story about someone who was using an API keys from an AWS bucket from USGS, and someone at USGS accidentally deleted that bucket.
Oh,
yeah.
Wow. Oh.
So thank.
That's
Yeah.
it's a
That's why I asked that question. So thank you, Chirag.
Thank you so much.
I will move on to our next speaker. Our next speaker is Jeffrey Stano from NASA's Global Hydrometeorology Resource Center, Distributed Archive, Active Archive Center, who will present NASA's Field Campaign Explorer. So I think.
Okay.
Thank you.
Oh, we're already sharing them?
Yeah.
All right, great. Thank you. And thank you for the introduction. And yes, I originally came out of NASA's Short-Term Prediction Research and Transition Center when I was a contractor there. And I thought, that's a pretty long acronym. I'm not going to be working for anyone longer than that. And now I am. So it keeps it interesting at that point. But no, thank you. Good morning to everyone and to everyone online. We're going to be presenting, this particular talk is going to come from a slightly different perspective than the first two talks that we've heard so far, which have been great talks to listen to. And Trevor, we're going to talk about the radar displays. But what we're looking at here is working with this FCX system, and we're trying to integrate a lot of the NASA Earth science data into our operations. Many thanks to my co-authors for this, and for everyone over at the University of Alabama in Huntsville. So quick background of what we're going to do. I'll talk about GHRC DAC, some of the issues that we're facing, and then the types of data sets that we're trying to work with right now. So this is not all encompassing. NASA ESDIS has a massive amount of information. So we're just kind of focusing primarily on what we do at GHRC, show some demonstrations and some of the demonstration, some of our future work here. As we mentioned, I'm from the Global Hydrometeorology Resource Center. We are one of 11 DACs distributed across the country. And really our goal is to make sure that NASA's Earth science data is freely available to the user community. That is whether it's a research group, is that universities, this can be also international and domestic collaborators. So it's a pretty wide-ranging user base that we work with. Each DAC also has kind of its own capabilities and kind of points of interest and expertise. Ours is in hazardous weather, lightning, other types of features like precipitation, things like that. For myself, I'm the DAC scientist. I'm actually a meteorologist working in the computer science department. So if you have detailed questions about the development of this, I'll send you the email to the developers. So where are we going with all this? So as I said, we are designed to archive and make freely available all of the data sets that NASA is trying to create through Earth science. So that means we're processing, archiving data, creating the documentation to say, okay, this is the data set, here's the metadata associated with it, and then making sure it's out for the community to use. Science enablement is a major component of this. We don't want to just be a curator of data. We want to help the community actually work with these data. And that is how ESDIS is going to be evolving. So right now we're known as the DACs. Over the next year or so, we're going to start evolving into the science enabling teams. And that's going to align with the 5 spheres that NASA is working with, the atmosphere, biosphere, cryosphere, geosphere, and hydrosphere. So just want to kind of put that out there so that if you start looking for DACs, that name is kind of moving away as we evolve into the sets. So let's start talking about what is the issue that we're facing with here. And as you kind of notice, I'm not necessarily talking about any of the real-time stuff right now. By our nature, we're not necessarily working in near real time, although our capabilities can be converted into that if we need to. But we do know that science research is not done in a vacuum. We're having to work with, you're trying to cross-reference with different things, radar with other observations. ARM is pulling in lots of different details. So you look at all these different types of data sets and how do you analyze that? And on top of that, you have airborne, ground, satellite-based data sets. They could be point data, three-dimensional data. They could be curtains of information or plan view data sets. I mean, it's just a lot going on. And kind of some sample images on the right of just a setup of a field campaign, the upper image, and then some satellite data from the upcoming INCUS mission. So this really starts getting us into what is the operational issue that we want to address. we want to kind of combine all of these different types of data sets. How do we work with them? And these missions are bringing together expertise from across the spectrum of opportunities. So what we want to do with FCX is make sure that we're capturing the knowledge of all the experts that are out there. So JHRC, I mean, yes, we're developing this and we're working with initial visualizations and things like that. But ultimately, we want to make sure that this can be a tool that others can use and can build on it. Again, they're the experts. I mean, we work with a lot of the data sets, but again, we're not always the expert in that data set. So we think that FCX is going to be a potential solution for that. So what exactly is FCX? It's designed to be a three-dimensional visualization, data visualization exploration tool. We're really trying to bring together, looking at multiple data sets in 3 dimensions, be able to both visualize and analyze them. Originally, it was built primarily for the field campaign data sets that JHRC archives, hence the original name FCX, the Field Campaign Explorer. We're now evolving that as well. So we're turning into AT&T. It used to have a name, but now we're just the acronym. So it's the FCX system now. We have some, this is a open source and cloud-based system. So it's designed so that anyone can take the software and kind of build and expand on it. And also it is that cloud-based component really helps because ESDIS and EOSDIS, we're trying to move all of our data sets into the cloud. And so this helps with kind of that interaction of using the visualization system with the data sets where they are located. So kind of a start here. The best part of here about being able to use these various movies and things like that is that everyone likes to look at the crowd pleasers. I can say whatever I want and nobody's really going to be too mad at me at this point. But when we look at this, what's nice about this is the system underneath all of this is we're working with cesium right now. Reason why we kind of work with this, bring in data as you zoom in and zoom out. So you can do this pan and zoom. You can look around to see what's going on. As you see through here, we have multiple data sets being displayed. The green line here is representing the flight track from the NASA ER2. This little curtain through here, that's the cloud radar system. We're looking at the electric field lines across here. And also, as you can see the cursor moving around, you can highlight various information and metadata from some of the lightning data that was being observed from satellite-based information at the time. And again, this is just kind of a nice way to just kind of show what we're aiming for and how we're trying to put this together. So what else can we do with this? This comes from the National Science Foundation funded Lake Effect Electrification Campaign. And I like this one because this was a weather balloon that was launched from the University of Oswego. And what's interesting about how weather balloon data is typically displayed is it's assumed I launch a balloon and I plot the data over the launch site, all the way from the ground up to wherever the balloon goes. We all know that's not actually what's happening. The balloon, in many cases, the balloon can go tens to hundreds of kilometers away from its launch site. So this is kind of a fun way to just kind of look at that and see what's happening over time. Where is that balloon going with relation in time and space to other data sets? In this one here, we're just kind of plotting the track and showing the wind speed and direction as it ascends into the area. I have another one that's kind of interesting. You can see where they hit the GPS gate and you can see the balloon then just drop to the surface. And if you'd ever imagined me going snowshoeing in backwoods of New York to retrieve radiosonde instruments, I would have been highly skeptical until this campaign. Another one, fun one here. This is, again, we saw the ER2 just go flying by from the CPEX campaign. This is a drop sonde. So again, very simple visualization, but from a meteorological standpoint, I like this because you can see, oh, hey, this is where the drop sonde went. And we can look to see that path. We can see how it evolves. And then you can also then click on this and you can get the SKU-T log P display showing that vertical profile of what we observed from that instrumentation. So again, not a very exciting visualization right there, but again, showing the power of that three-dimensional capability. And imagine if you see that with additional data sets on it. So to wrap up here in the last 2 minutes, the way we want to kind of see this going forward as well is we want to capture the knowledge that the experts have. And what we can do by making this open source, the experts know how to visualize their own data sets, but they don't know how to visualize each other's data sets. So if we can bring this together, so other groups can kind of work together, we can integrate their capabilities into our system, or they can even take FCX and go forth and do their own thing with it. And in addition to that, we can then spin off these Jupyter notebooks. And I see some heads nodding through here. And what's nice about this is that we have linked this into the NASA OpenScape system. so that we can access the Python libraries that are available through there. I think, Trevor, you had mentioned this about trying to work with Python libraries. That is the bane of my existence, trying to get any of those to work ever. And so what we can do, I see this as an opportunity to serve as a data recipe. So every data set that is visualized, we can spin that out into this notebook. And it really serves as an opportunity for users to say, hey, how do I crack open this file? How do I do a simple manipulation of the data set and go forward with it? And so with that, as we go forward, we are going to be working with the Investigation of Convective Updrafts, or INCUS mission. This is going to be a combination of satellite data observations and subsequent field campaign for verification. They've already had a pre-launch campaign called Time Slice, and we will be using that as a demonstration for their upcoming post-launch campaign called PySlice. So with that, again, we're hoping to kind of continue to expand this with more Earth data holdings, put the rest of my group's information up there, and thank you for your time. This has been a fun opportunity.
It's great, Jeffrey. Thank you for that. Do we have any questions in the room or online? If you have any questions for those participating online, please feel free to type them on Slido.
Thanks. I'm Liz Hoy at NASA, and I work on other airborne campaign data sets and collections. And I really liked this viewer, and I like how you're trying to get it in like OpenScapes and think about other ways to use it. But it's an issue that keeps coming up: is how do we show the airborne data along with the field data? And we're looking at an open source tool called MMGIS.
Yes.
And I wondered, is there a way to integrate these two together, or think about this as more of an even larger problem across NASA and other agencies? Like, how do we have some standardized tools that are more available that show these different types of data sets together?
That is an excellent question. And the answer to that actually dates back to November of 2024. There is a group bringing a lot of the DACs together. It was called our User Working Group Summit. You might be familiar with this already. We held this out at Langley. And we had some discussions say, hey, wait a minute, how do we start integrating? The DACs have several different tools. I mean, Oak Ridge has Soot. I know GSFC has done some work as well. So in short, yes, the answer is yes. I think we need to look into how do we integrate this? And that was one of the answers that came out of that discussion in 2024. I think going forward as well, there is as this is realigning, there's also the organization, the suborbital archive readiness team that's standing up. Yes, the SOAR team. And I think SOAR is looking at all of this as well. And Stephanie was in here just a moment ago. We can touch base with her. But I think that's one of the opportunities that we have to, I think SOAR can kind of serve as the way to help guide all of us. Say, hey, wait a minute, you three, start talking. You're welcome. Thank you.
And Bobby just told me that we have a question online. Do we have Chris? Chris?
Yeah. I was looking for Slido, but if it's okay, I'll just throw it out. My question.
Go ahead, Chris.
Okay.
Yeah.
So thanks, everybody. This is really, really exciting, at least from my perspective, all the speakers so far, and I'm looking forward to the next couple presentations. Jeff, I'm really curious if you could say a little bit more about the conversation about the decision to go open source with your tool. If I understand, it's still relatively new in that sense. So I don't know if you have a lot of experience with others adopting the tool and, versus sort of standing it up and running it for people, that kind of thing. But, we've been nosing around that conversation on our side. And I'm just curious, how you all approach thinking about that.
Another great question. A lot of where we're looking at for this, are we as operational as what we've seen with the first two talks? No, we're still a little bit. We have been kind of slowly developing it and kind of as time permits and as funding permits to go forward with it. And the emphasis to go into open source, that has been kind of our effort to push this forward within ESDIS and to kind of design this as more of a quote unquote enterprise level tool for all of ESDIS versus just a GHRC specific tool. And that's kind of where we have been looking to go forward with it. And also at the same time, too, the open source aspect, opens the door to kind of capture the knowledge from the users. Because GHRC, yes, we can put the visualization stuff together, but we can only do so many data sets at one time in addition to everything else going on. And also, we may not be the expert in that particular data set. And so the open source capability allows us to capture that knowledge from others, or they can just run with it themselves. They can make their own instance of FCX and run with it that way.
Great, thanks.
You're welcome. Thank you.
If we have no further questions online or in the room, thank you, Jeffrey. And we're going to move to our next speaker, who is Victor T. From Disaster Imaging Incorporated, presenting the SASE application, which is Situational Awareness for Severe Storms Interception.
So this really gets started in 1993. The first version of SASE was written in Objective-C on NextStep, and graphics were done in Display PostScript. There was no open source anything during this era, so the GIS also had to be built in-house as well, using USGS CDs of Tiger data that were reprocessed into a compact binary format for faster input and output. And then field tuning was done via putting the long tertiary roads, having those explicitly mapped in a different format, since you need to know that when you're flying at 60 miles an hour. In 1994 and 95, it was proven in Vortex. This was SASE's very first real-world deployment under the verifications origins of rotation and tornadoes experiment, and it showed that it worked. But there was one big caveat, though. The field coordinator had to poll each team directly, asking for a position, and they responded with their own latitude and longitude. So unfortunately, there was no automatic key, and each field team was having to participate in a picture that they themselves were not able to see. In 2002, there was a big leap. Suddenly, you didn't actually need to ask the coordinator for anything during IHOP. The research aircraft from NOAA was able to now start transmitting meteorological data and put the ground images into one picture. SASE pulled the latest NWS bridge radar images from a federal URL and overlaid them onto the field data. And then finally, unfortunately, the same limit remains. You had a single computer on the field coordinator's display, and not everyone had a shared picture. And in 2007, there was a rewrite for SASE. An NSF grant funded SASE, and it gave shared awareness to everyone. It was rebuilt in C++, in Qt, and it was available for everyone if they had a Linux or Windows device. For the Mac users, there was a very brief port, but this is Mac in the early 2000s, and you can probably guess how that went. In 2009 and beyond, it carried Vortex 2, Rivers, and then Taurus. However, there was an issue as the 2010s continued. Mapping was SASE's biggest limitation. Commercial providers like Mapbox and Esri were starting to come online and be available, but they were not very stable with the original form of SASE written in Qt and C++. And I actually witnessed one of the major faults during Taurus Light in 2023. Bobby's laughing because he remembers exactly what happened here. SASE went down completely, and it couldn't be repaired until the campaign finished. And obviously, if you're running the field campaign, losing that shared picture and spatial awareness, not really a good thing. And Bobby really remembers that. But SASE is back. Introducing SASE Legacy. So the reason I chose the name SASE Legacy, SASE was always meant to do more than it was originally able to be. I'm a software developer, and I came up through meteorology at OU, got my undergrad in 2025, and I finished with my master's in data science in 2026. And I'll be the only one working on it, which, might raise a couple of eyebrows, but this is what I'm trained for. I'm a software developer by nature, and this is what I'm explicitly trained for. I don't need to carry the science. I only have to carry the software forward. This is built from a clean sheet code base. This is not a Portly Qt app or anything of that nature. So now you get CAMs, you get meso-analysis in the view as your teams, and you're able to move forward that way. Alrighty, we'll give it a go. So it would be a little bit easier. Obviously, the rest of the talk kind of, mattered on the demo. So there's, I guess, three main priorities at the moment. So the first one is original features. So a key thing in software, you're asking from people to move to an old platform to a new one. It's parity. So bringing messaging, radar, graphical annotations, and field status is the first thing. And then stability. What happens when you have a downlink and anything of that nature. This is a direct answer to what happens in 2023. And then the biggest leap forward is model analysis, which is priority 3. So bringing forward the CAMs and other model providers to be able to see it in one viewing. Unfortunately, that's the heaviest lift item, so it could potentially trail the rest of the application. Unfortunately, there was, going to be a lot more I could have shown you through the application, but, unfortunately, not being able to show the demo. Yeah. Is there, I guess, any way I could potentially try and show it?
Well, go ahead.
Okay, finally, something of some semblance. Sorry about that, y'all. Also, I'll just throw that out there. If any of y'all have any questions, because I really kind of just had to rush through it, come find me afterwards or shoot me an email. So getting started here with the map. So you have all of your field teams here. So your mesonet vehicles, a UAS, a probe, and your target area here. And just like a classic toggle, you can hide what you want, put what you don't want, and anything of that nature here. And then I do give, based on some user feedback from some old users of SASE, they just wanted kind of a plain radar with nothing, very similar to your radar scope. So that's what I do here and I give for you. So your classic fields, here you have your station selector, your fields, reflectivity, velocity, ZDR, that follow all the standard NWS color tables because, well, I don't want anyone learning a new radar product while they're actually deploying or chasing a storm. So you get split pane, you get quad, not quite Trevor's with his 1,000 radar panes. Maybe we'll see if people want that. And then messaging here. So you have everyone, just observations, now casting logistics, and then your different priority levels. If you see something that someone should be aware of, you're able to alert them on that. And then you're able to upload any images or anything that you're seeing there. Data, you can actually look at all the data streams. So one thing that I think Trevor over here might find interesting, and obviously this is a demo, you'll be able to view radar data off of a radar truck if it's streaming or see any past images. But the one thing that I do want to feel slightly different kind of moving forward is going to the forecast mode over here. Oh, one thing to mention, most field campaigns, at least whenever I participated, we always started with the source of truth, and that was the Storm Prediction Center. So I give you all of the outlooks here. You have categorical, tornado, wind, hail, along with the discussion here. Maybe you can mark it up as you please. And then moving on to the models here, composite reflectivity with your controls. You can select your models here. None of these fields individually are supposed to be new, but now they're all in one place. So instead of having to go between COD weather, pivotal weather, or any other provider, having it all in one place so you don't have to keep going is, I think, going to be the future where things like this should be taken. So, and then obviously you have your SBC meso analysis. And again, we saw a super composite like that, supercell composite like that, that would be very extreme, but obviously this is just a demo. But obviously, sorry for like the technical difficulties that you're there. And if anyone has any questions, yeah, I'll open the floor.
Do we have any questions for Victor? He has the live demo and you can go and speak with him at any time. I think we're going to have a birds of a feather lunch. So if people want to, so the speakers are going to come together for lunch. So I encourage people to come as well and then ask questions and share knowledge. Thank you, Victor. Despite the technical difficulties. Let's move on to our final speaker, who's Carol Ruchti. And she's coming from the NCAR Earth Observing Laboratory, and she's going to be talking about the EOL field catalog.
All right. Thank you all. I really appreciate everyone who's participated in this session. All these tools are very alike, and it's been really great to understand how there's a lot of overlap in them and what we're able to create. But I'm here today to talk about the NCAR EOL field catalog. This will be another quick demo, as you've seen with the other folks here today, just to get a taste of what is all available. But I have all 4 of the other folks that work on the catalog team listed there below. Okay, so what is the field catalog? This is a beautiful sentence that I've written for an overview paper I'm writing, so I didn't just come up with this, but it's a sophisticated, customizable, real-time application for planning campaign operations, tracking field campaign research platforms and displaying real-time products. Overall, it's a web application similar to what other folks have shown today, and it's been around for a long time. And we've already talked a lot about field campaigns, but just to provide some initial context, I'm viewing field campaigns as short to medium term scientific projects where researchers leave the laboratory to collect real-world data directly in the field. And so I briefly mentioned this, but the catalog has been around since 1995, so almost as old as SASE, actually. Didn't realize SASE had been around that long as well. It was inspired by the early internet browsing available in the Mosaic browser. And, there was this initial thinking like, wow, we have something that everyone can view through something called the internet. And it's a great way to put all of the catalog or all the field campaign information together in one place. And then in 2013, we made the GIS mapping tool called Catalog Maps that really was a big breakthrough for the catalog as well. So the catalog has gone on to be a key application for atmospheric field campaigns now for the last 30 years. So this is what the homepage of the field catalog looks like. I have a QR code if anyone wants to open it and have a look themselves. I've kind of viewed the catalog as having 4 different pillars, them being real-time data products, real-time platform tracking, fully accessible reporting, and playback of events. So we'll step through what each of those look like. And then, the homepage there is kind of this one-stop shop like other people have mentioned with their tools, but displaying the latest visible image for a project that's going on right now in Salt Lake City, an ozone study. And then we have the plan of the day and other time information available on the homepage as well. So once again, it's kind of nice. I got to go last year, but a lot of people have already showed what some of these real-time products look like. Sometimes we make them ourselves as the catalog team. Most of those are the satellite imagery, which is very easy to access now. If NOAA or NWS are making web products, we can pull those web products and also put them in the catalog, which is really useful. And then the science team and the PIs can also generate their own products that we put in the catalog. Okay, so this is what a looping of some of those real-time products might look like. This is cloud development over Salt Lake City for the project that I'm most recently working on. And that's another great way that we can view the products from the catalog. And then here's another quick example of aircraft tracking using imaging layers in our mapping tool. This was a project from 2021 with 2 aircraft being the Learjet and the G5, watching them move around on their missions, and also the satellite image is updating in the background as well. So that makes for great playback for people that are, maybe looking at the field campaign 10 years after it's been completed. So I mentioned fully accessible reporting. I'm mostly thinking about this in the context of at least your reports aren't sitting in a Google Drive that might, be owned by someone else and might not exist forever. Now we'll have it on the web, thinking about keeping these catalogs available for maybe decades after field campaign has ended. So folks can upload mission summaries, instrument notes, aircraft operations, and of course the elusive plans of the day that hopefully don't change, but sometimes they do. And then I just wanted to share some feedback. I've kind of been trying to focus on collecting survey information after we run a field campaign, also doing interviews with users, but these were a few pieces of feedback that we really appreciated, saying that the catalog makes field program mission planning and post-analysis so much more efficient and effective. I can't imagine having a field program without it. And someone else saying, I'm confident that we will continue to use the catalog for years to come. So this is obviously very motivating and helpful for us to continue to understand that the users enjoy our tool. And just some final thoughts to kind of end this brief run through of the catalog. We've had great success really focusing on what users want, and we've tried to align with that for the past few decades. As I mentioned before, adding the tracking and the mapping for catalog maps, I think really was a breakthrough and is now probably the most popular part of the catalog. And one thing that I'm thinking about, and I think the other speakers are often thinking about too is how can we continue to make higher quality data visualizations to add in achieving field campaign goals? Like, how do we aid in the science? What kinds of additional software development could we make to create even better science into the future? And then lastly, one thing that we've been thinking about more recently is, can the catalog be utilized for science stories that sit outside of atmospheric field campaigns? We've really sat in this niche, as most of these other tools have as well. Is there, another interesting way that we can display this Earth science data in contexts that maybe fall outside of atmospheric science as well? And one challenge is always going to be staff and timing. Everyone would agree with that, I think. I always am trying to think about, wow, what else could we add to the catalog to make it even better if we had more resources? With that, happy to answer any questions.
We have questions in the room for Carol, and
I went extra fast because we were running behind. As the organizer,
I think what's going to happen is we'll ask questions for Carol, but then what I want to do is open up the questions to everyone from this point onward. So questions for Carol first, then questions for everyone else. I think did you have your hand up? You had your hand up.
Hi. For the tracks, for the aircraft tracks, is it a particular format for like the nav data for that, or is like what are the options for pulling that in? Either in real time or after, especially after the flight.
Yeah, Chris Webster at NCAR has developed something called an IWG1 packet, which is a very specific string that we use to pull in the data that goes into a database. But more recently, I've also even just pulled positions from FlightAware. And so FlightAware has its own API that you can pull that information from. It costs like a very minimal amount, but I've done that as well to do. We probably could. I mean, I don't see why we couldn't in the future. It just requires some development time and money. Yeah.
Hi, this is sort of a hybrid comment/question. I'm Steve Young. I'm a retired EPA guy, and I'm kind of a weather geek and a biodiversity enthusiast. And so going off of your last bullet point about other possible use cases, I've been thinking about relevance of this kind of work for biological field campaigns. I think about a couple of analogies. One is so-called bioblitzes, where within a finite period of time, teams deploy to try to observe as many organisms as they can within an area and, collect the data and report it. So a lot of this work in terms of coordinating field activities of biologists, I think could be an interesting other use case. But maybe one that's a little bit closer to the mark for this work would be bird migration. And that, as probably everyone knows, radar is really nice for tracking migrating birds during peak migration periods. And there's some really cool stuff going on now with showing both what's being seen in real time and what's forecasted. And the birders are using that to target where do I want to go to find a bunch of warblers, because you could see based on both what the radar is showing and weather forecasting and current observations, there's probably going to be a big bird fallout at this particular location. So I think not only your work, the catalog might be a good launching point, but also the visualizations. I just think I was sort of encouraged thinking about applications that start to interface with the biological world and field work, people who are going out there, and they do try to coordinate, like the birders. Wow, I found this really cool bird, and then they converge to look at the cool bird. So wanted to kind of throw that out there, but also, invite you to react to that.
Yeah, I think the limitations that I think all of us have in these tools that we've displayed or, presented today they're mostly time and space based, right? And so birds happen in time and they live in space. And so I think the context doesn't even have to just be earth science like you're suggesting. It really could be biological and things like that. Obviously, some of these tools are a bit more niche, but yeah, we've really tried. One example is more of a social science take. Someone did surveys for Hurricane Ian and trying to understand if people evacuated or not. And that's like did you stay? Did you leave? Can you map the survey results on a map as well? So yeah, I'm thinking about all those kinds of ideas, but that's a great suggestion.
More questions for Carol or online?
Also, while we're giving the mic to Bobby, if you want to go onto the Slido, I put the QR code up there. We're going to kind of open it up to other questions, especially to add people online. So.
Yeah. And I guess if there was some opportunity to open, right? So like you talk about beyond science stories and had a lot of good discussion about like the field observations. Have there been dialogues or are there open dialogues between, say, your group and the National Weather Service, for example? I know that obviously every field project is different and different data provides different value to forecasters in real time. But interested to know if there's a pipeline there or at least open communications, like when a field project starts, you communicate with the local office at the very least and say, hey, we have this data coming in. Here's where you can find it in real time. I know that's something we try to do, but obviously there are a lot of limitations there as well.
Yeah, that's a great point, Bobby. I think there's more to be done in that area. And I think that there's certain PIs are much more invested in working with the National Weather Service, like you're suggesting, but maybe some of the onus could go on us too, to say like, oh, just here's the link of the catalog. If you want to have a look at anything, we're running these operations during these times. I think that's a great idea to engage those groups a bit more because they could really benefit from field campaign real-time observations as well. Thanks.
So as people are maybe filling in the Slido, and it's okay if you don't, I would like to open up the floor to general discussions, general questions. Are there features that you saw in any of the presentations that captured your imagination and sparked your interest? Are there features and applications that you would like to see in any of these tools? So the world's your oyster. Be creative. Be curious. We have a question.
Thanks. So I was involved in Vortex, and these field campaigns have years of planning, right? To write the science proposals, to get all the field equipment there. You finally get into the field. You have 6 weeks with dozens of vehicles, hundreds of people, and you're trying to find a tornado in the case of Vortex. And we didn't do very well at that time. We found very weak tornadoes. But I have to bring in the question about AI. And I imagine this AI agent that helps direct the missions using tools that came from machine learning to predict where the storm might go in terms of historical events, and then gives the PI some suggestions on where to put the mobile radars, where the aircraft should go. And so I wonder, first of all, where are we in that time cycle? And then what are the next steps? Is there a pilot project that we can use to do some AI? I know the catalog has a lot of imagery. Do we need data as well as the imagery? And some of these other tools have imagery due to bandwidth limitations and things like that. Or can AI just take that imagery and use it as is? So
I was wondering when someone was going to bring AI. If no one was, I was going to bring it up. But here we've got some responses from the panel.
Yes, this is Jeffrey. That's a very interesting approach to what you're talking about. And we, for the FCX stuff, we may not have gone quite that far with our thinking with AI, but where we've kind of started thinking about it is you may have an instrument that flies on the ER2 or something like that. And it flies many, many times. But one of the big issues, again, as you know, is that each time it deploys, it's a little bit different. I mean, the lessons learned or new capabilities have been added, things like that. What happens to us on the back end when we're trying to display that information is that suddenly the code that was used to do metadata extraction and everything like that no longer works because it's different on the next deployment. The advantage is that possibly with these AI tools, things like that, you can create some sort of system that can say, wait a minute, this is the cloud radar system on the ER2. We know what it should look like. We've seen how this is how it worked previously. this is how it's changed. We know how it should look with details. Can we use those kind of AI clients to kind of help us kind of modify the input? So instead of us having to manually create the ingest each instance, we can give it one and kind of build off of that. So a more simplified case, but that's definitely.
Victor?
Hi, I don't think I caught your name. Mike Daniels. Okay. I'm Victor. So funny enough, Eric and I, we had kind of been conceptualizing all the way back in 2024 of when, kind of he was looking at me to maybe take Sassy over. So my question is, would this be an algorithm to basically, depending on what vehicle you are? So like, let's say you're a Mesonet truck, for example. Okay, you're here. Storm will potentially be here. And then this is where you should be in order to do a transect or based on whatever. Okay. So I experimented just kind of on my own time. There's two possibilities I think of. So for example, if we're doing maps based, using A star, which is like Google Maps, search algorithm, and then you can plug that into some kind of a data feed that pulls in like radar images and something like that. And then you can run a neural network that takes these images and it makes its best prediction of what it's going to do there. Or the experimentation that I've actually done kind of recently, and I think it's a very fascinating use case, is you take a small LLM or a small language model and you strip away everything to where you're just left with a large language processor. You run some reinforcement learning that's just on meteorology, and then you let it go. So I actually did that for SPC. I took 20 years of data of, I think it was href, and then I gave it to a language model, stripped everything away, and then actually performed pretty good this year. So maybe look at the LLM path potentially, especially the small ones you can download.
Anyone else from the panel?
So it's slightly unrelated, but something that recently I also found out is not all AI is LLMs, and it's not AI is agentic AI. Something that I've noticed with ARM as well, like especially with ARM data sets, is it's a lot of data products have been machine learning driven. So what they have done is they have done this pattern detection algorithms where they've taken one field campaign at a time. They have seen some pattern detection using a lot of graph neural networks as well. Just continuing what it just triggered to me that a lot of those GNNs have the capability to infer your data in the sense that it can give you enough patterns to see whether this kind of situation worked for a given field campaign, for a given data product, or for a given instrument. And nowadays, what ARM is also doing is they're taking that same approach to continue and find, like, probably you can call it as anomaly detection or something like that for different field campaigns. So that's the lessons learned. Not entirely connected, but they are using this kind of AI approaches as well to find out where a good region or where could be a good urban area can be for conducting different kind of campaigns. Yeah.
Hey, Susan. This is Susan Stringer from NCAR EOL, and she's one of the field catalog developers. Yes.
Hello, everyone. I'm kind of switching directions here a little bit, just about the user experience. And I was just curious about, especially for some of the older applications where you have people who've used the same application, the same UI for 30 years, and then introducing new things is scary. And then you have the newer young students, and they are used to a different thing. And so what I was just curious about is how do you poll your users and figure out how they're using your application?
So I know, as brief as my talk unfortunately had to be, during the design phase of kind of Sassy, when I was taking the old UI from the Qt version and kind of rewriting, the short demo that y'all saw, I took I took it from several groups of people. So, for example, I've been a storm chaser outside of field campaigns. I've seen 33 tornadoes. What would I want in my dream weather application? So I started there, and then I asked my other friends. And then I went to someone of Eric's generation, a little bit older. And then I kind of just went backwards like that. And then my brother, he's 12 and a half years older than me. So kind of the 30s to 40s range, knows nothing about weather, but he is a UX designer. And I brought the design forward that I showed. And I said, is there anything that you can see? And I gave him my MacBook, which has radar scope. And then I gave him the radar scope from my phone. And then all of the relevant pages. Is there anything that would cause anyone from my age to, just a much older generation? Would there be any user friction there? And if the answer was yes, like I mentioned, if it takes you more than a minute to figure it out, I'm going to treat that as a bug, because especially in a context, where you potentially have a rain wrap tornado breathing down your neck, you don't want to be figuring something out on the fly like that. So I think that's kind of the way that I approached it. I'm actually, Trevor, I'm a little curious on like your perspective on it, because I feel like our applications are a little almost similar.
Trevor, you want to respond?
Sure. I sort of developed Guru 2 in a vacuum. I got a lot of feedback from my coworkers at the time, and just sort of went from there, just trying to make the most intuitive program I could. I definitely have noticed there is an envelope of age ranges that vibe with Guru, about my age plus or minus like 15 years. And yeah, I'm not really sure how to square the circle with like new students that are coming into our field projects, trying to learn it. I have lots of feedback. There's one of the unexpected benefits of my design of alpacas and sort of siloing away those coordination features, like behind a username and password, is Guru 2 is just like out there as a free download on my web space. And I discovered this year like an actual like a vibrant community of mobile radar interested people that there's more Guru 2 power users in that community than there are at work, which is nice. Like it's been a hugely useful resource, and I've gotten a lot of valuable feedback there. Just going out into the community and finding users that I didn't even know about, but not a lot I've been able to do yet, just for lack of bandwidth. But yeah, I don't know if I really answered the question.
I have another. Okay. I'd say one approach we've taken is that, again, slightly different organizational setups, that we have a user working group that we can poll and say, hey, what do you think about this? Additionally, I mentioned at the end here, we're going to be working with the INCUS mission, which is both satellite and field campaign data. We're getting embedded with their science team. And so we're going to be working with their science team to kind of help guide where we go with this. Because right now we're kind of relaunching it, because we developed it. It's been kind of stagnant for a while due to funding and things like that. And now we're trying to get restarted.
Yeah, thanks. So one thing I didn't hear about in any of the presentations, but I'm sure it's being addressed, or probably, is terrain. And obviously terrain matters, right? And I'm interested in what you have to say about terrain integration, and including both impacts on storm behavior, but also if you're chasing, right? And you won't be able to see it if there's terrain, right? And you might want to know that, so that's my question.
Does anybody want to respond to terrain or incorporate the idea of terrain in your field application?
So SASE's new map will be using Mapbox, and you can plug anything you want. There's actually very specific terrain maps where it's like paved, unpaved, or like any kind of questionable service or like surface that you might be driving on. So it's not quite like the very original version of SASE where things were shaded completely differently, but you'll be able to see topography and all of those different things there. Just that's baked into the map provider.
And just to Victor's point, where he was like surveying, across age ranges, I think expanding to family and friends would be welcomed as well. So rather than stick to a to a siloed user base of fellow scientists and collaborators. Have your family and friends take a look at it as well. Carol.
I think since you went back on the whole, how do we collect feedback from our users comment? What Susan and I were involved with doing these user interviews earlier this year. And I think those were quite useful in having virtual meetings with users and recording them using the tool, like through a screen share and a meeting recording is like, whoa, they can't find the button, or like, wow, we need to make something bigger, more obvious. And it can be really eye-opening to do that. But to Trevor's point, if you have the time, and like it takes a lot of effort to come up with a script that you can use for these kinds of interviews. So it's worth the effort, but it's not something you can whip up in 2 seconds either.
Victor, did you want to have the final word before we adjourn? Okay. I just want to be mindful of the time. So it's 12:30, but the conversation doesn't have to end here. So we've reached the goal of starting that conversation. But I think Carol has organized a flock of friends of flock for at lunchtime. I think we have birds of a feather.
There will be no birds, just people.
But I think we will have a lunchtime table where the speakers and folks who are interested can come together and continue this conversation. So once again, thank you everyone for participating. Let's thank our speakers and ourselves. Thank you.
Thank you, Jackie.
Everybody online.
Thank you, Bobby. Thanks all.